there's a survey that's published in Computer World, and it's called the Software Engineering Meeting Benchmark Report. And it found that most engineers spend nearly a third of their week in meetings. And um, if you break it down, it found that about 20 hours were spent in focus time, actually working, concentrating. And then 11 hours were spent in meetings, and then 6 hours in kind of fragmented work time, not really focused, and maybe checking email or doing other things. Now you notice that only is 37 hours, so there's a few hours that kind of just bleed away because they're so fragmented that they kind of bleed away. That was the results of the survey. So unless we do something intentional, only 20 hours a week tends to be, on average, what's spent actually focused on really working to do what we think we have them on payroll to do. All right, let's break that down a little bit more. Um, if we have fragmented work time and if we have meetings and then we have focus time through um, other quality trends, on average, half of a developer's work time tends to be fixing bugs, fixing problems, as opposed to developing new changes, developing new features. And we kind of get that, general half and half from work from Capers Jones and other surveys, but that's that's been corroborated a whole lot. So if you take focused debugging and focused development, and then your fragmented work time and then meetings, you get um, you get kind of this 27% of the work week on focused development. So let's just simplify that down to 25%. You know, a quarter of the work week is what you think that one of your developers is working on the entire work week. And obviously that's kind of out of alignment. So why is this happening? What's causing, besides the meetings problem and the fragmented work problem, why is half of the rest of the time going towards problems? And of course, we need to have the conversation about how to stop that and reallocate. So let's look at this. There's four different cycles, and I'm simplifying. There's four different cycles in a software team. You have making individual code changes on the developer's workstation, and many cycles per hour. Then, when the code is shared with the team, a pull request, then we jump out to the next cycle, which is at the team level, and we have a build and pull in the pull request, do a build, produce a new release candidate for the software application, and we have a new version, and so we push that out to the next level, which is typically product team or someone in the business unit that we're serving, and they look at it and run it through its paces and check to make sure that they're happy with it. And then once they're happy, it's cleared for production release, and then we push it out to production where some customers start using it, or perhaps the actual people in the business unit, and they're using it. So we have these various cycles. And going all the way back to the 70s, it's kind of proven over and over again that a defect that escapes out to the actual user of the software are an order of magnitude at least more expensive to remove. And some surveys have found two orders of magnitude more expensive to remove. But I think anyone who's been in software for a while understands that if a defect jumps from one of these cycles to the next cycle outward, it's significant. For example, if there was a problem in the software and I, as the developer, find it on my workstation and fix it, yeah, I fix tons of these things, in minutes. But once something escapes and it's pushed out as a pull request to the team and some other people are looking at it, well, in order to fix it, well, now even for simple things, I'm at least an hour. And if the team sends, internally to the business unit that it's serving a release candidate to look at, well, and then the problem is caught there. I've got to send it back. It's multiple hours, maybe multiple days. And then if it gets pushed out to production and the users are using it and the bug is found there, then again, we're at days or maybe, now we're into the weeks. So um, that just tends to happen if a defect escapes out one of these bands of process. Now, from studies of over 19,000 software projects and research compiled by Capers Jones, we know that only 40% of defects are actual problems with the code. There's problems with server configurations, there's problems with data, there's problems with analysis where a decision for how something was supposed to work that was then faithfully coded, that could be the defect. And also 9% of the time that we fix a defect, we introduce a new and different defect. And this is where the vicious cycle comes in, of fixing defects, and then we accidentally break something in a seemingly different part of the software. But this general environment makes it hugely costly to allow defects out. So the engineering practices that we employ are very, very important because um, because how to establish quality is a project in and of itself. Because if we don't establish quality, we will get sucked into this vicious cycle of rework, and then all of our team's time is going to be sucked into fixing problems, and a smaller and smaller and smaller piece of the weekly pie will be spent on getting new features down the road, and then the software project slows and slows and slows, and then weeks go by and months go by, and we're not getting anything done. And then the executive that allocated all of this budget for the software project, they're asking, where is this going? And all we can talk about is how hard our people are working and the long hours they're working and coming in nights and weekends. And no doubt, yeah, they're spending extra time, but they're just spending extra time fixing problems. They're not actually getting more done. Okay. And that's why it's so important that you are equipped as an effective software leader.